Hello everyone, note down this question. It's a convex mirror of radius 20 centimeters. On its principal axis, an object AB, let's say a marker, it lies like this. Not in this manner, but along the axis from A to B. And length of this object is 5 centimeter. This distance is 15 centimeter. And A of the object is at a distance of 15 and length of the object is 5 centimeter. Length of the object you can say is 5. Find out length of the image. Convex mirror of radius 20 centimeter. This is your object AB. Length of the object is 5. Find out length of the image. Should not take more than 40-50 seconds. Try to answer this. Look here. Can you tell me where image of this object will be? On the left side or on the right side? Can you answer this part? Where this image is going to lie, left or right? Look, if you remember, I had told you that in your car, the side mirror, it's always convex. So when you're looking at an object in this convex mirror, this is the object, and if its image forms like this, if image forms like this, A dash B dash, then I think you can answer that something like this you never observed. And A is closer to the mirror, but in this, and B is closer to the mirror, which is like saying you have a car, and when you are looking at that car, the front bumper, if this is a car, let's say, in a car like this, so the front bumper and this is the rear bumper, if you form an image in this form, then what basically you are saying is that this is the front bumper, not this. What you are saying is this is the rear bumper and this is the front bumper. image parts. Now, I hope you can see that this is something which is not possible. What is not possible? What you are finding is that the car, let's say, is approaching you. Forget about this arrow. Object orientation is AB. Let's say this is the object and it's moving in this direction. This is giving the velocity. In this setup, this will be the velocity. That means what? Car is moving away from the mirror. Whereas, look at this car. This car is approaching what? Your convex mirror. And therefore, this type of orientation is not possible. So, first of all, you always find what? A virtual image of a real object if mirror is what? A convex mirror. And this type of orientation is something which is not possible, which in itself is a short answer type question. Now, as we know that object is not going to be formed in this manner. So that's how it's going to form. A dash, B dash. This is the image. Correct presentation. And I'm asking you length of this image. Li. What do you need to do? Find out VA dash, position of A dash, and similarly find out position of B dash. If you can find position of A dash and position of B dash, then Li is simply what? VB dash minus VA dash. A and B, these are 2-point objects, and for these you will use 1 upon F equals to 1 upon V plus 1 upon U. Focal length you can see is 10. Radius is 20 centimeter. On the right side, focal length is plus 10. We need position of A dash, U. As an object, A is on the left side 15, on the left minus 15. This gives us VA dash as shift LCM and simplify. This is 1 upon VA dash. That is, your VA dash is coming 150 divided by 25. Same thing for B. When you go for position of B, this will be 10. This thing will be what? Position of B is not 5. Position of B from the pole. From the pole, position of B is what? 15 plus 5, that is what? 20. This is 20. You get 20 multiplied by 20 upon 20 plus 20. This will be 1 by 20. This is 10. This is 1 by 10 plus 1 by 20. So your answer will be 20 into 10 upon 20 plus 10. that is 200 upon 30. That's your VB dash. This is your VA dash. Subtract and you get your answer. Wrote down everything. Wrote down this question. It's a concave mirror. This is a convex mirror. They both have 10 centimeter radius. Centimeter. An object of 4 mm height is placed at a distance of 5 and 5 from both mirrors. 5 and 5. Call it M1 and this is your M2. The question is, first reflection from M1, second reflection from M2. Light falls on M1 and then is reflected and falls on M2. After that, the image you get, you need to provide each and every information about that image. First, write down the question. Find out properties of image. Find out properties of image formed after first reflection from M1 and then second reflection from M2. You need to provide whether the final image which you get is real, virtual, erected, inverted, enlarged, diminished, everything you need to provide. At a distance of 5 centimeter lies your object from both mirrors. Let's see if you can answer this question. Look. Question says first reflection from M1. This is origin, O. If this is the origin, focal length will be what? R by 2, F1. For M1, F1. Radius is on the left side, -10, -5. This is the origin. Look at the center of curvature. It is on the left side and therefore R is what? Negative. F1 is coming -5. Now look carefully. When we'll calculate for M2, origin will be shifted over here When you shift your origin to this point, your F2 will be R by 2. When origin is at this position, radius of curvature, center of curvature is again on the left side, and therefore it will also be -5. Both mirrors, one is convex and the other one is concave, but you can see that they have same focal length, -5, -5. What you need to remember is when you are dealing with this mirror, its pole is the origin. When you are dealing with M2, its pole is the origin. And then always take care of plus and minus sign as you do with X and Y axis system. So, this is your focal length. What is distance of object? 5 centimeter on the right side, and therefore U1 is +5. For M1, 1 upon F, 1 upon V plus 1 upon U. Focal length is coming minus of 5. 1 upon V plus 1 upon U is coming 5. V is coming minus of 5 by 2 centimeter. Minus 5 by 2 means image forms over here at a distance of 5 by 2. That's your image. This is the image. Regarding magnification, HI upon HO minus of V upon U. U is -5, U is +5. V is coming minus of 5 by 2. This is coming 1 by 2. We need HI. HO is given as what? 4. HO is 4. This gives us HI as 2 mm. And I've already told you that you don't have to convert millimeter into centimeter because this is centimeter upon centimeter. This is millimeter, and therefore HI you directly get in what? Millimeters. So here lies your image, which I have shown with broken lines. Broken lines. This height is 2 mm. HI is coming positive. It's an erected image. Lies on the back side and therefore is virtual image. Reduced in size, diminished. Now, this image is going to act as an object for M2. Use this formula and get me everything. Put on this much and then proceed from this 2 mm and 5 by 2 centimeter. Tell me this. Let's call it I1. I1 is a virtual image. What type of object I1 is? Real or virtual? Answer this thing fast in the comment box. I1 is a virtual image. Why? Because it forms behind the mirror. Virtual image. What type of object it is for M2? When we go for second reflection, this is going to act as an what? As an object. So what type of object it is? Real or virtual? Good. The same virtual object is in front of M2. Anything in front of the mirror is real. Anything behind the mirror is what? Virtual. So the same virtual image acts as what? Real object. Real object for M2. Virtual image for M1. Behind. Real object for M2. Now, for M2, again use the same formula, 1 upon F, 1 upon V plus 1 upon U. Focal length, this time this is your origin. Focal length is -5. Sometimes people think that for convex, focal length is positive. For concave, it's negative. And vice versa. No. Always remember what? Take this point as origin. And then things on the left, negative. Things on the right, positive. 1 upon V, this is what we are interested in, 1 upon U. For M2, this I1 acts as an object. What is the distance from the origin, from the pole? 10 plus 5 by 2. So this distance is coming 10 plus 5 by 2, 12.5. Is on the left side minus. 1 upon V is coming 1 upon this 12.5, you can write as 2 upon 25. Shift minus 1 upon 5. V is coming minus of 25 by 3. Roughly 7 point something. Somewhere here you're going to see your image minus 25 by 3. Let's see the orientation part also. For M2, HI upon HO, this is HO, 2 mm. I'm using this formula, remember, directly for M2. HI upon HO, HO is 2, plus 2 above the principal axis, minus of V divided by U, which was minus of 25 by 2. This gives us HI as minus 25, 25 cancel, 2 into 2, 4 by 3 millimeter. So your final image lies in front of M1 and therefore is what? Real. And the size is coming 4 by 3. This is shown with red arrow. Now look at the negative sign. It's an inverted image. It's an inverted image. This is your final image. Let's call it I2. Inverted. Size is what? 4 by 3 at a distance of 25 by 3 from the pole of concave mirror. This completes the answer. Note down everything. Now, repeat this question, but first reflection is from M2 and second reflection is from M1. Find out position of the final image. Should not take more than 30 seconds. First reflection from M2, second reflection from M1. For that, find out position of the final image. So we need to answer position of the final image when reflection is such that first it takes place with M2 and then it takes place with M1. What is focal length? R by 2. Take R with sign left minus 5. That means what? This object is placed at the focus of M2, 5 centimeter. The focus of M2, F2. This is nothing but F2. Everybody knows that when object is at the focus, image forms at infinity. If image forms at infinity, that means you are saying that for M1, rays are coming from infinity. If rays are coming from infinity, then intersection takes place at what? The focus. Where is the focus? Right here. Its focal length is R by 2, which is minus 5. This is F2, 5 centimeter. So rays coming from this, when reflected by the M2, move parallel to the principal axis because They are going to meet at infinity. And if they meet at infinity, we say that for M1 rays are coming from infinity and final image I2 is going to be found at this position. Without any calculation, using simple statements, we have answered final position of the image at a distance of f2, which is 5, on the left side of M1. Don't get confused with I2. I1 is for the image which you get after first reflection. I2 is image which you get after second reflection. So this is the position of final image. This f2 I must change, make it f1. Let's make it f1. I2 is the image after second reflection, 2 for second reflection, which falls at the focus of first mirror. Is this thing clear? Yes or no? And if you wish, you can use the calculation part also. For M2, 1 upon F, 1 upon V, 1 upon U. F is what? -5. We are looking for V. U is what? On the left side, at a distance of 5, -5. This immediately gives us what? V as infinity. This and this cancelled. 1 upon V is coming 0. That means V is coming what? Infinite. For M1, 1 upon F, 1 upon V plus 1 upon U. 1 upon F is -5. We need V. What is U? This V is U for second reflection. Infinity. 1 upon infinity 0. You immediately get V as what? -5. -5. This is the calculation part. Now let me draw the ray diagram part also. Let's take this object as a point object. First reflection from M2, second reflection from M1. So rays are going to move like this. This is the incident ray. This is the incident ray. Rays coming from the focus. If you place an object the focus, they are going to become what? Parallel. They are going to become what? Parallel. Now these rays will be reflected. These rays are going to be reflected. These reflected rays appear to be coming from this position. This is your I2. That's the ray diagram. That's what is happening in this figure. Note down everything. Now, who is going to tell me final orientation of the image? We know that if it's a point object, you're going to see it over here. But it's a line object. So what is the final size of the image? Final size of the image? Real or virtual? Erect or inverted? We have found the position. Now get me other properties of the final image. Let's see if you can answer this. The image which you got, is it real or a virtual image? Erected or inverted? And what basically its height is? Answer these parts. Look here. Let's find out magnification for this. Hi upon Ho. I'll call it Hi1, Ho1, 1 for first reflection. If you wish, you can continue with 2, 2 also. There is no issue in that also, but 1 stands for first reflection, first image. Hi1 upon Ho1 is minus of V upon U. What is U? 5 to the left. What is V? Infinity. V is coming infinity. Let's remove this part. V infinity I have used over here. Ho1, let's use directly. Ho1 is 4 millimeter. 4. This gives us Hi1 as 4 multiplied by infinity divided by 5, which you might think is basically coming infinity. Yes, it is. But let's continue with this. This is your Hi1. Now, second time when we go for, this is for first reflection. For first reflection, and now we are talking about second reflection. Second reflection, Hi2 upon Ho2. Hi upon Ho minus of V upon U. We are interested in Hi2. What is U? For the second mirror, rays are coming from infinity. This U is infinite. V of the first case is U for the second case, because you don't have to adjust this 10 centimeter, because from infinity when you add or subtract 10 centimeter, it's going to remain what? Same. So this V is infinity. U therefore becomes what? Infinity, which is also clear from this ray diagram. V, we have found final position is over here, minus of 5. we need Hi2 multiply HO2. Now what is HO? What is HO2? Hi1 of the first case will be HO2 for the second case. Whatever is the image after first reflection, you know that it's going to act as what? An object for the second reflection. So this is the image after first reflection. It becomes what? Object for the second reflection. So I'll be using Hi1 in place of HO2. Multiply HO2. You can also write like this with a different color, that this Hi1 is going to act as HO2 for second reflection. So when you multiply, you're multiplying 4 into infinity divided by 5, this number with this number, which is 5 upon infinity. This is the reason we continued with infinity. Infinity and infinity cancelled. 5 and 5 cancelled. Answer is coming what? 4 mm. So you have got same size object, 4 mm. Final image is also what? 4 mm. Hi is coming plus, that means it is an erected thing. And since it lies behind M2, behind M1, since it lies behind M1, it is going to be what? A virtual image. So this is your virtual image. Shown with red. This is your I2. I hope everything is visible. They both are of same size. But the final image is what? A virtual image. The only thing important was what? Do not multiply with infinity. If this becomes infinity, then you lose information of 4 and 5. You just need to remember this, which in maths is called taking limits. So we have basically found the limit. There was an infinity present, there was another infinity present. If you multiply something with infinity, the whole thing is basically infinity divided by infinity. So it was not defined. We took a limit and then we found that a limit exists and the value is coming what? 4 mm. Do you understand this calculation part? How to remove infinity from the calculation, and this red virtual final image? Yes or no? We have a convex mirror of 5 centimeter radius. An object is at a distance of 20 centimeter and is moving in this direction with a velocity of 3 meters per second. Object is approaching the pole with a velocity of 3 meters per second, and we need to find velocity of the image. There is not sufficient time and therefore I will answer this. Look at the approach. 1 upon f equals to 1 upon v plus 1 upon u. Remember, v is not the velocity, v is position of the image. U is position of the object. If you have been given position of the object, how do you find velocity? You differentiate that. If somebody says this is x, this distance, then dx by dt will give you what? Velocity. So for finding velocity, we need to differentiate the whole thing. Remember this part when you are dealing with concave or convex mirrors. Focal length is a constant, differentiation will be what? 0. Whatever be the position of object in front of the mirror, your focal length is what? A constant number, differentiation is 0. 1 upon v, its differentiation is 1 upon v square into dv upon dt. This is coming from differentiation. If you have y equals to 1 upon x, then you write it as x to the power minus 1, which gives us dy upon dx as minus 1 x to the power minus 1 minus 1. But if I don't need dy upon dx, if I need dy upon dt, then I must write the whole thing as into dx by dt. This is from 11. If you're not comfortable with this, tell me and I'll give you a lecture on that. So if you need differentiation with respect to x, it will be minus 1 upon x square, minus 1 upon v square. But we need differentiation with respect to t, and therefore we need to add dv by dt, dx by dt. Then 1 upon u, its differentiation will be minus of 1 upon u square, u du by dt. Differentiation of sine x with respect to x is cos x, but differentiation of sine x with respect to t is what? Cos x multiplied by dx by dt. So differentiation of 1 upon v with respect to v is this much, but with respect to t, dv by dt. Differentiation of 1 upon u with respect to u is this much, but with respect to t, this. So we need what? dv by dt. Shift, you get a negative sign, transfer v square upon u square into du divided by dt. Now, in this whole thing, what is v? Distance of image. So when you differentiate that with respect to time, and that distance, remember, is with respect to origin, pole. So with respect to, with every sign, you can consider that as kind of displacement defined with respect to what? Origin. This dv by dt is coming with proper sign, is giving you what? Velocity of the image. You need to find v. How do you find v? Use this formula. When object is over here at a distance of 20, u is what? Minus 20. Focal length, you know, you can always find what? V. Find the v, put it here. U, you already have. What is du by dt? Object, its displacement or position with respect to origin is what? 20. But displacement on the left side, and therefore you have taken u with a negative sign. What is du by dt? Velocity. What is direction of velocity? Positive or negative? You will say positive, and therefore you take plus 3. So let's put the values. Find the value of v from this calculation. That's your work. U, we already know, is minus 20. Du by dt, write it like 3I cap. This is what I cap. Once you find v using this formula, you can find what? Velocity of the image. So very easy profile. Even if you don't understand this, remember that for mirrors, that's how you find velocity of the image. Note down this much and then you can leave. Thank you very much.